Have here an automatic pressure control for water pump. This pressure control water pump is serving 28 bathrooms, 3-story building. So our water tank is 8-ton water tank, and the problem with this pressure power pump is the pressure control. So the pressure control is not working, so I think this one is damaged, although the water pump is working good. So that means we have to change the pressure control, and we will be changing the same model, the same capacity there. So first we have to remove this one. We'll be removing the output plug here, and then so we can remove this pressure control. Okay, we have here the automatic pressure control that we removed from one of our project, because this automatic pressure control is damaged, it's not working. So we will open this so we can find what is the causes of the damage for this pressure control. We have here our water pump. In this case, this automatic pressure control is installed immediately at the top or the load side of the water pump. However, if in any case this can be installed 5 meters vertically above the water pump. At the same time, this can also be installed 5 meters horizontally from the water pump. Okay, so within that distance of 5 meters, you cannot install or fix anything there, like for example pressure gauge or tap or faucet for that matter, because this automatic pressure control will not work as you can be expected, because within that distance there will be an issue for head loss. If you will install it beyond that, like for example 6 meters, it is not advisable because of the head loss issues. Now here we're going to open this. So this is the actuator. This one here is the actuator or the safety valve, commonly known as the safety valve, and this one here is the electronic chamber. So we're also going to open this, and this is our pressure gauge. Okay, and this one here is the stem, or simply as the pressure chamber. Okay, so we will have to dismantle all of this so to find out what is the problem with this unit. Okay, this system, if it is installed, this is also commonly known as the booster pump. Okay, so we will open this. We will remove this screws here. Okay, so the screw has already been removed, and now we will try to remove this electronic control card. We will see what is the problem or what is the cause of the trouble with the water pump. Now here, as we can see, one of the resistor at the load side or the power supply is busted. You can see it's broken already. It may be blown off. Now at the control side, two of the transistor there is broken. That is also damaged. It's also burned out, and then part of the card is also damaged. So this electronic device is totally garbage. So our decision to change the automatic pressure control is justified here. Okay, now here, as you can see, I cut off a small portion of the stem or the pressure chamber here so that we will see what is inside. And as you can see here, this one here is the bulb. This is usually, they call this as the puppet bulb. This should be freely moved up and down, up and down. Okay, now assuming that the motor or the water pump had stopped working, okay, and the pressure inside the chamber and the whole system had reached its desired level, okay, and the position of this puppet bulb will be closed this way, and the actuator is compressed because of the pressure inside the chamber and the system. Now, the moment that any of the valve or faucet or the tap is opened in the load side, the pressure in the chamber and the system and also with this diaphragm will be reduced. As the pressure is reducing, this actuator will push down, okay, it will expand as this actuator expands, the diaphragm will be pushed down because of the absence of the pressure, and as the pressure is losing, then this electronic device here will detect the absence of the pressure in the chamber, and then it will give a signal to the water pump, and then the water pump will automatically work. Okay, as the water pump works, this bulb here, this puppet bulb, will be pushed up. It will be pushed up to give way for the water to come inside the system to give supply water to the open bulbs and the open faucet, open tap inside the system. Now, the moment that the bulbs, the pumps or the water faucets and the taps are closed and shut off, the pressure inside the system, including this chamber here and the diaphragm, will accumulate. So the pressure, as the water pump is working, the pressure inside the system will accumulate, and as the pressure is accumulating, this diaphragm here will push this attain, and as the pressure is accumulating, this electronic device here will detect the pressure inside the chamber, and then it will give a signal to the water pump to shut off. And when the water pump shuts off, this valve, this puppet valve here, it will close, and so that the air and the water will not escape from the chamber, and so the pressure will be maintained constant inside the chamber. Okay, so now what are the possible causes of the burnt out electronic card here? So sometimes inside the water tank there are some foreign materials like sand, pebbles, or silt that are being pumped out by the water pump, and that could causes the hindrance to this puppet valve to move freely. And that if that happens, the abnormal presence of the water pressure inside the chamber will send a wrong signal to the electronic device here, and that could cause an abnormal response from the water pump, and that tends to overload the resistor due to an overheating. And another thing that can cause this damage for the electronic card is the presence of water inside the chamber. So the plastic cover should be tightly closed. So this project, the type of this project that we installed today is a downstream system. So downstream system, that means that our load side are all going down, meaning that our supply source of water is in the highest elevation, and our supply load is in the lower or lowest elevation. So this is, we installed 1/2 horsepower. Usually we installed 1/2 horsepower pump for the downstream, because the downstream, the gravity is already present in the water, so that means that you will only help push the water so that you can have the constant pressure of water distributed equally to each outlet. Now the other type is the upstream. So in the upstream system, you will have to determine first what is the highest elevation wherein you are going to supply the water, and then the number of outlets, the volume of the water that you are going to supply. So you have to compute that, and then so that you can also compute the total head loss, the number of turns of your pipes there. So you will determine how much head loss that you are going to include in the system, so that you can design capacity required for the upstream system. So you need to compute the loads, the head loss, and the total volume, and then compute for the total power required for the water pump. So that's it.